Hello guys. In this video, we will solve one blind 75 LeetCode questions. We will start from the beginning. Let's try to solve the array problem to sum in Python. As you can see, the problem is first LeetCode problem. It's a to sum, very well-known problem, and it's an easy. The problem asks, given an array of integer nums and an integer target, return the indices of the two numbers such that they add up to the target. So basically we have given an array of integers and also a target. We want to find out the pair which actually sums up to this target value. As you can see, if you add these two numbers 2 and 7, that becomes 9. So we'll return basically 0 and 1, the indices of these two values. For the next test case, 3, 2, 4, the target is 6. So we want to find two numbers whose sum is up to 6. So if you add up 4 and 2, it becomes 6. And the output would be the indices of these two values, that is 1 and 2. Before starting to find the solution, let's talk about a few of the clarifying questions you should ask to the interviewer. One of the questions you should definitely ask, do they want all the pairs, right? Because if there are multiple pairs, which indices need to be returned or not, right? For this problem, they want only one answer, right? And another thing is actually in the LeetCode criteria, only one valid answer exists. That means there would be at least one pair. So as soon as you find a pair, you can exit out of the program. That's the main thing. Second thing, you should think about how we approach the problem. Obviously, we can go brute force method that for each of the pair, for example, number 2, we can go to each of the values in nested for loop and check if the target is 9 or not. So for 2, we will go through the whole loop 7, 11, and 15, which will be n minus 1. And for 7, again, we'll go through all of the numbers. And for 11, it will be all of the numbers. In that case, the runtime complexity would be order of n square because you are basically going through each nested loop for all the values of outer loop. Next question is that, can we make it better? So if you want to make it better, we need to think about some trade-off between space and time complexity, right? So although the brute force method is order n square time complexity, good thing is that you don't need any space to store anything. But if you want to solve it better than order n square, you should think about how we can store some intermediate data so that it can be reused later. For example, when you are going through the first number 2, can you store this value so that you can check that value in a constant time? So one of the ways we can solve this problem, basically, we can store all the value in the dictionary of Python or any hash map or hash table data structure for other languages. The good thing about hash map or dictionary is that it's a constant time operation. So if you know the numbers, you basically need to find out where it was located. So for each of the number, we can store the indices so that we can easily look it up. In that case, if we, for first number 2, basically we are looking for 7 and we don't have anything in the dictionary. So we would not find anything. Next time when you are looking for 7, you are looking for something which is diff 9 minus 7, 2. And if you already seen 2, then you can just return those 2 indices. Based on these 2 things, we'll go ahead and implement this algorithm. So for this one, we basically have given a list of integers as a numbers. So if you want to see all the values in numbers, you can just do print numbers, right? Now, there are 2 ways to enumerate the whole list in Python. So if you want to just need the numbers, you can just write for n in nums. So it will give you all the numbers. If you want all the indices, so for example, IDX, you can do range, basically len of numbers, which will give you all the indices. But you need both the indices and also the numbers. So there is a interesting way to use that one. So you can basically use IDX index and also the value in, you can use the enumerate function in Python. So if you do that, then basically you get all the values with the indices and also the numbers, right? And if you want to just try it out, just return none for now. And you can run the code, you'll be able to see, you see all the values like index and nums. So let's do n. So if you run it again, you'll be able to see, you get the first is the index and second is the value. So if you use this function, we'll be able to store the value. What we are looking for, we need a dictionary to store all the values what we already have seen. So we can store it as a dictionary, which would be basically a key value pair. And for each of the numbers, we want to see what we are looking for. We are looking for a diff, which is basically a target minus n. And if we have seen that value, diff in seen, we can basically return the result. And for this case, you want to return the result with 2 values. And the first value would be what you have already seen. So basically seen of diff and this current index. And in each iteration, you basically want to add that value to that index. So you basically want to write in the IDX. And since the result exists for all the cases, you don't need to return anything. And that should be fine because in the LeetCode, they said actually one valid answer exists. So let's run this one and see actually what we are getting. So basically we are looking for 9 and the output is 0 and 1. And for case 2, you will see we are looking for 6 and the expected output is 1 and 2. And for 3 and 3, you are looking for 6. So basically the answer is 0 and 1. And since at least one valid answer exists, we don't need to test for the null case or empty case. And you can hit the submit button to see if there is something wrong. So it can beat almost 100% of this problem. Other solutions. So that's how we solve this problem. This is a pretty easy problem, but one important concept is that if you have seen a number, you want to store that value in somewhere in a hash map or dictionary so that you can use it for later uses. That will be useful for solving some other later problem in the LeetCode. That's all for this video. Thanks for watching and stay tuned for the next video.